Welcome to Physics 1, Physics 11.01. My name is Paul Francis and I'm lecturer and convener for this course. I'd like to start off by talking a little bit about what we're trying to achieve in this course. Now, most of the physics you've probably studied at school, you will have focused on learning about how to solve a particular type of problem, practicing it lots of times, doing it in the exam, and then forgetting all about it. But our goal in this course is a bit different. The world has many problems and is really going to need brilliant research to address them. And the people who are going to be doing that over the next few decades are you. So what we want to do is train you so that 10, 20 years after you graduate, whatever job you're in at that point, let's say you have a problem to solve, a problem that we can't even imagine now. We want to give you the skills and knowledge that will allow you to solve those problems, to know how to start on something totally unfamiliar, something that no one in the world has done before. And that's a very different skill from what you've learned mostly at school. The first section of the course, we're going to be covering what we call ninja physics. This comes by a variety of names. Some people call it Fermi problem, some people call it estimation, some people call it back of the envelope. I like the word ninja physics because it's very fast, very powerful, but doesn't stand up well in the light of day. The basic idea is that when faced with an unfamiliar problem, you make huge approximations. You focus on only what matters. You get rid of small factors, forget about factors of 2 or 3 or pi or something like that. So you approximate it, come up with a very simple model, and get a very rough answer very quickly. Now this might seem a bit perverse. Why are we teaching you to give rough approximate answers when we could give exact ones? Well, in the real world, you've got some unfamiliar problem, something you've never seen and no one's ever seen before. You're going to have lots of ideas about how to approach it. Maybe we could do it this way, maybe we could do it that way. And most of those ideas are going to be wrong. For most brilliant researchers, I'd say maybe one idea in every 10 works. If all your ideas work, you're clearly not having imaginative, challenging enough ideas. So if you've got a whole bunch of ideas and most of them are not going to work, what you want to do is take each idea and very quickly work out, is it even in the ballpark? Is it even vaguely close to being useful? And that's what ninja physics does. It allows you to work out very quickly what might and might not be useful. So you can discard the ideas that are not, and then focus on the ideas that are going to work, and then start adding in the more details, worrying about the factors of 2 and pi and getting every decimal place right. But the first step is a very approximate calculation in almost anything you're going to do. Now, there are 3 principles of ninja physics we're going to focus on in this course. One is what we call going to first principles. When faced with some unfamiliar situation, going to first principles means asking why repeatedly. Saying, why do we do things the way we do? Is there some real reason for this? Is there some law of physics that forced it, or some law of economics? And probing down layer after layer. Because this is the way you come up with truly novel and exciting ideas, by digging below the surface to find out what's really going on. A second key idea of ninja physics is that you should focus on developing a model. What is a model? We never solve the world as it really is in physics or any other subject. We always have an approximate model for it. So for example, if you're calculating when a ball flies through the air, you're assuming that the ball is all the atoms moving together, which they're not, of course. They're jiggling around and so on. But we're approximating it as a single object. That is an example of a model. It's a simple version of the world. And a crucial part of all physics is coming up with models that are useful. There's a famous quote, all models are wrong, but some are useful. So we have to simplify the world enough that we can calculate it, but do so in a way that's going to give us roughly the right answer and not leave out anything vital. The third key point is to focus on the most important things. It seems obvious, but often I see people doing a calculation where they endlessly worry about should that be 2.03 or 2.04 when they've actually got the units wrong, and so they're actually out by a factor of 1,000. In any problem, we should focus on what really matters first. The really big things are going to make a huge difference. Only after we're absolutely sure we've got them right, we've understood the physics that's going on, should we start worrying about the small details. So these are the 3 points of ninja physics. So now, let's start.